Hello, welcome back to PLSQL tutorial. In this tutorial, we are going to discuss about overloading in subprograms. So let's try to find out something that been asked. Let's say we have an employee table EMP where we have a number of records, all right, and then one of those is employee number column, name, department ID, and some other things like salary, bonus, manager, and all this thing. And then we have number of rows are here. Let's say I ask you to determine, fetch me a record based on employee number or employee name or department ID or department number. So let's say basically this is the question that has been asked to you. So write a function. That function is going to take either an employee number, or it can take an employee name or an department number, and it will fetch the complete record. Okay, complete record of the complete row it's going to fetch. So this is our requirement. Then what you can do, you can create a function f1, and this function f1 is going to take a parameter called p underscore employee number. Okay, and then you basically in the spec you define this function f1, and then you declare this function f1, and in the package body what you can do, you can query the employee table based on employee number is equal to p underscore employee number. And then you are going to create another function called f2, and that f2 is going to take here p underscore ename, that we're going to take a varchar variable that is the employee name. Okay, and then again you are going to define this function f2, and whenever you are going to query the employee table, you are going to query select star from employee where ename is equal to p underscore ename. Similarly, if you want to do for department number, then you are going to create another function f3, and f3 is going to take a variable called p underscore department number, and you are going to query the employee table based on department number is equal to p underscore department number. So what essentially you are doing, you are creating three different functions f1, f2, f3. So this is fine if we have small number of things, but imagine like if we keep incrementing, in a complex scenario, these kind of things can go over. Essentially what you are going to do, probably you are going to forget that there is a function f3 that is going to take department number as variable. So instead of that, but if you see what all these functions are doing, these functions are doing a specific work, and that work is go to the employee table and fetch a record based on whatever I'm giving. So instead of having three different names, why can't we have one name, and we are going to pass different types of parameter. In one case we are sending a parameter that is a ID number, in another case we are going to varchar. Okay, so we can do something, basically instead of f1, f2, f3, what we can do here is an example. We call a function, that function name is get underscore emp row. Get underscore emp row is going to take one parameter called p underscore employee number, that is a number kind of variable, and is going to return a employee record. And see, like this is the first function. Second function is exactly the same name, but the variable, the input variable, instead of a number I am sending a varchar. Okay, so now, and after that what I did, I to define my package body. Inside the package body I implement get underscore emp row, and with the first parameter as a number. So if it's a number parameter, then this is the query that what I wrote, and then I return x. Then I am going to create another function, but this function is going to p underscore l name, and this should be varchar. this is a mistake, varchar, and then here is the query. So if you see, the difference between function 1 and function 2 is the query. All right, but whatever it is, but what I have done here, I have overloaded the function get underscore emp underscore row. Okay, so what this overloading concept is, basically it enables you to create two or more subprogram with same name, and the name is get underscore emp row, and we have two such functions which is same name, and then these are called formal parameters. Okay, so what we're going to do, we are going to change the formal parameters. In one case we are sending a number, in another case we are sending a varchar 2. Say for example, whenever I'm going to execute, so let's say I do an execute, let's say this package name is xyz dot get underscore emp underscore row. If I give a it's a varchar, let's say king, in that case this function is going to be executed. So basically the execution will happen at runtime based on what kind of parameters I am sending. If I am sending a number parameter inside get underscore emp underscore row, then the first function is going to be executed. Okay, so essentially what we are doing, we are overloading this get underscore emp underscore row. We make sure that we are going to send different types of formal parameters. Okay, so this basically essentially helps us, enables us to build flexible ways for invoking subprograms with different data. All right, so this is what is called function overloading or procedure overloading or subprogram overloading. Same concept as you have done in C++ or sorry C++ or Java, where we basically same name, but at the runtime it's going to determine which function is going to be which program unit is going to be executed. Okay, so having said that, so let's see, like what cannot be done. So for example, the restrictions are like this. So here in this function I have a function f1. F1 is p underscore number, and it's a number, and if another time, like I have also same function f1 but it's decimal. But look, number and decimal, they are of same data type, same basically family of data type. Okay, so therefore you cannot do what I have. So let me just increase this font so that you can see it better. Okay, so this is 22. Okay, so I'll just pull it back. Okay, so basically what we are showing here is that this is not legal, because this p underscore number is already defined. There is a function name f1 which is number, and decimal, they are of same family of data type. Therefore this is not allowed. This is also not allowed because you cannot just change the return type. You need to have different input value. Okay, the rule is that the formal parameters cannot be of same family of data type. Okay, so that means you cannot just say that in one case it is returning a number, in another case returning a varchar, so therefore this is okay. So this is also not okay. So this is what we are talking about, how we can basically use function or subprogram overloading. All right, then let's discuss about something called built-in. So let's say we have a function called toChar. So this is a standard function that we use in SQL and also using PLSQL. So let's basically, for example, if toChar 5, then what this is going to give me, this is going to be a character representation of 5. If I say to underscore char and then I give a date, say sysdate, and then I give a format string, say mon, so this is going to give me say January. Okay, so what you have seen here, that all lot of our built-in functions are highly overloaded. So based on what kind of, see for example in toChar, in first case is going to take a number variable or only one variable, whereas in second case is going to take two variables, one is date, another one is varchar. Alright, so this is called built-in functions, and these built-in functions are highly overloaded, and they belongs to a package called standard. Okay, so the way that you access our demo package by calling demo package dot function f1. Similarly, you can access the toChar by calling standard dot toChar. But since this is a standard function, we do not really have to basically say the standard dot toChar. Thus toChar is going to work. However, what you can do, you can create, let's create a package, say create package p1, package name. Okay, and I'm just basically doing the body, and then what I'm going to do, I'm going to override this toChar function. So what I have a function called to_char. So I define a function here, to_char, and this to_char is going to print, going to return hello. All right, and then this is end function, end of toChar. Then I have another procedure inside that package body. Say let's say procedure p1, and inside that procedure p1, let's say I am calling to_char 5. So in this case, what is going to happen, to_char is going to be called in this, basically the function that we have overwritten, that is going to be called. So that means whenever you have overriding a built-in function or built-in procedure, and then if you are calling from that context of that package, then the overridden procedure, or this is, let's call this is called local. Okay, so this local to_char is going to get first preference. That means in this case, like if I want to say put this toChar into a variable called x, instead of 5, what I'm going to have, I'm going to have hello, because toChar of this package is going to be called first, but that is the preference. All right, so therefore toChar 5, if I have overridden, then if I call to_char, then the overridden function is going to be called, and since the overridden function is giving hello, therefore x will be assigned to hello. However, if I call x is equal to standard dot to_char 5, in that case to_char 5, whatever the standard function, standard package is going to be called, and this is basically going to give me x is equal to 5. So this is how you are going to do the built-ins. You can override a built-in, but generally we don't really do those things. But yeah, you can, inside this package body, you can essentially override the predefined system given PL/SQL functions or procedures. So next thing we want to do something, discuss about forward declaration. So let's see a PL/SQL procedure, PL/SQL package. Let's say I have created a package body. So I have my first procedure is procedure p1, then begin, end. So inside this procedure p1, let's say I am calling procedure p2, and this procedure p2 is defined after procedure p1. So procedure p2, and this procedure p2 is a private procedure. That means it does not have any reference in your package specification. Okay, so therefore procedure p2, and then we have begin, and then we have couple of PL SQL statements about procedure P2. Then whenever the control is going to come here, so this is basically called forward reference. Okay, so essentially what we are doing, we are referencing a procedure P2, and that procedure P2 is defined later on in your package body, and compiler is going to fail because compiler is not going to able to refer or resolve the reference at this point. So in that case you have two options. Either you define this procedure P2 first and then define procedure P1. In that case procedure P2 is done, and then whenever the execution comes to procedure P1, and then we know already because P2 is there. However, this is not a good solution because a lot of times this package body contains 40 to 50 subprogram units. So in that case, for readability point of view, we often what we do that one, we write those things on a alphabetical order. Okay, so we write those PL SQL procedure and functions in an alphabetical order inside the package body. So in that case we can never guarantee which one is going to be called where. So in that case what you do, after create a package body, just tell the compiler that there is a procedure called P2. Say like what I'm saying is this program unit is going to work alright if we just add a piece of code called procedure P2. This is just a declaration. Okay, so this is we declare here. So if you declare like this procedure P2, and then all these things can work without any problem, because the compiler knows that okay, so there is a procedure P2 which is defined somewhere down the line, and then so whenever it's going to refer here, so it knows that there is a procedure P2, so therefore it's not going to give you any compilation error. And this is what is called forward declaration. Just remember that procedure P2 must be a private procedure or function. If had it been a public procedure, then in the package specification we have given, that means the compiler knows it, not a problem. Only the problem occur when you have a private function or procedure and you are trying to access that private function and procedure before it has been defined. In that case, compiler is going to give you an error. The solution is to declare the private procedure function just after the package body, so that compiler will know that these things are there. This is what is called forward declaration.